Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. Sorry about that false start there. I forgot to hit record as usual. But we're recording now. Good to go. This I called Flip Flop, and I'm going to tell you why in a sec. Basically, you'll notice from a couple weeks ago, I still have this up because this is what we're basically going to be starting with today. But as usual in my demo scene streams, we're just going to sit down and make some stuff in the tool. Might be a shorter stream than it has been last couple weeks today, but we'll see. Anyway, what I want to implement is something that's actually should be fairly straightforward with the ray marching pipeline, but might have a couple interesting caveats that we'll have to see. But generally, it should look pretty good. Basically, what I want to do, I often scour Vimeo just to look for inspiration, really cool short films, all that kind of stuff. And one of the things I found is this piece called Marvelous Machines by Niels Prayer. I'm going to go ahead and link that here. In particular, it has a lot of like really cool shots in here, really cool ideas. But particularly, there's one shot in here that I thought would be good to make on one of these streams. And it's this part here where it has this sort of square thing here that's basically like taking over this like rectangle shape. And then it does this close-up shot here, where these are kind of like scaling and flipping over in these little like pixelated sort of cells. And I really like that motion. I really think this is pretty cool. And it should be relatively straightforward to do with ray marching. So I think this is a good candidate for some quick kind of thing that I can implement today. So I thought that'd be pretty fun. So that's basically what I'm going for. Not necessarily the materials or some of the lighting, of course, but just kind of that flip over effect. So we're going to start with that. I think that'll be pretty cool. By the way, hi to guys in the chat. Dark Second, Johnny Jelly Matt. Good to see you guys. Now, I was running pretty late, so I actually haven't cleared out a lot of the stuff in this project from a couple weeks ago. So I want to go ahead and do that really quick before I dive in too much. But I literally just want to get rid of some of this extra data down here. The reason I didn't start with just a fresh rocket project is because I have a lot of good default values other than the stuff I set up here. So just easier if I just copy and paste and then edit the other stuff. A couple of these are tracks that are specific to this other effect. I'm just going to leave those and just remove those from the shader. Zokwar, how's it going? So yes, I'm just going to remove more of this stuff here. So now the shader will basically not have anything going on in this case. Let me bump up my font size. Hey, Dana Colin. So yeah, get rid of a lot of this material stuff because we're not going to need it right now. Just comment out these lines here. I think you can just make scopes like this in GLSL. We'll find out. Basic material. Cha. Added a couple lights. Still probably won't see anything here. Yeah, because now I would have actually broken the shader. Go ahead and fix some stuff. We'll get rid of all this. Oh, whoops. I deleted the program that had the binding. Let me undo here. This is why we undo. Or this is why we have undo, I should say. That's kind of nice with the lights already. Fancy. Local hoster, how's it going? Studio C, hey. Yes, we are already moving towards something. Hey, baggers. Hope you're enjoying the wine that I presume you're drinking. For no apparent reason. I was over at Baggers' place earlier today, which is why I was running late. We got into very interesting micro-op discussions right as I left. So not to worry. A couple more geometry things I want to get rid of here, particularly like all these walls. Don't need them. We'll just take whatever the center object thing is. Which is apparently these cubes. Okay. I'm going to simplify that and just make it a cube. And it's over there. What else we got? Yeah, so this is actually pretty clean slate. Also, there's the floor, which we also don't need. And yeah, I'm just gonna move the camera so we're closer to stuff, closer to the action. And nice. Cool. Perfect. So now we have an okay starting point. So what I want to do is basically there's a couple parts to this kind of effect because there was the cubes that sort of flip over and then there's the stuff behind it. I think the main part is that sort of grid of cubes and that kind of thing. I think I'll just start with that. Of course, the easiest way to make that initially is just to make a grid of a lot of cubes again, which ironically is what we started with, but might as well just make it again from scratch. Should not be hard at all. In fact, we can do cube P is repeat X, P, and then something. So we'll do floats. We can call this tile size, actually. So we'll call these tiles. Yeah, so I don't know how big these are going to be yet. Make something up. And we'll also do repeat Y. So we'll just repeat on those two axes. 3. Now this will basically repeat forever. What we want to do here is adjust the cube size. So in this case, the tile size is 10. This should be that a little bit less than that over 2, which will give us this. So actually, this is like tile cell size. So if you can kind of imagine, each sort of tile exists here, and then they also sort of exist within a cell out of this entire grid. I'm going to adjust this a little bit. So actually what I'll do here for that's tile cell size, and then float tile size is going to be tile cell size divided by, now we'll do this. We'll do times 0.8, and then in this case, we'll do it divided by 2 here. So I'll do X and Y for this. And then we'll do tile thickness for the other one. Now we've kind of parameterized everything nicely, which always helps. So Mach83, how's it going? So now we can adjust this tile cell size. Get a nice tile size. Gonna want it to be pretty small. We can basically go as small as we need. Fancy. Oh yeah, more patterns. Classic. Also some interesting swoopy shapes there. If you can see this curve here. I'm guessing we're getting that just because we run out of iterations when we get really close to some of these edges. So that's actually the background color creeping in. We get these really grazing angles on the edges of these. Not going to be too much of a problem in this case, I think. However, so one of the things we need to do is we need to basically like flip these over or scale them. Probably a little bit of both, depending on some kind of pattern. So what I'm going to do is first I'm going to probably, I guess we can just adjust the tile size. So normally it would be the full size here, but then we're going to adjust that with some FBM stuff. In this case, we just need 2D FBM because the grid is going to be X and Y. Also, actually, we also should cut this off at some point. So I want to define some resolution stuff here. So we'll do X and Y res for this. So the tile size will determine sort of how big these are, like again within the cell size. So if we take like the cell size times this resolution here, then we'll get the full size of the thing. So to do that, we'll do yeah, this is the actual tile. We'll do this here. We'll say float D is the tile, because we can also say float bounds is something, and that'll describe the bounds object. We can do we only need to do the 2 dimensions, so we should be able to do something like something. A coaster likes where this is going. Add wireframes, runs away. I quit streaming for good. That is over the line. It's actually nowhere near the lines because I'm not touching wireframes with a stick. So bounds, Evil, how's it going? We want to do like, do bounds X is tile res X. Actually, let's make this a vec2. And then we can do tile res by tile cell size, and that should basically be it, except I want the bounds distance. Use tile D to make that consistent. The distance to the bounds is going to be abs p.x. I think we can just do max abs p.x, abs p.y, get the maximum of those two, and then we do that. That should give us a bound around it like this, and then we'll do I think it's just the intersection of this and then the bounds distance. There we go. However, we cut these off here. And that actually makes sense because we have even numbers of these here. Yes, because it's offset in the middle here. We can just do... The easy way to do this is just to make this an odd number and just deal with that. And I think that's actually fine in our case. So let's do that. And then, of course, the original, it was a lot taller than it was wide. So we'll just make that the case here, too. It was also a lot higher res, but we'll have to see how well this goes before we dive into that too much. I can always just drop this as well. It's going to be real small. Let me go ahead and reduce some things here. Reduce our field of view. Get a kind of nicer, a little bit of a flatter perspective on this, but actually, I think the wider perspective actually worked better here, so we'll just move closer. Turn my camera shake off. Hey, John Hunter. Let's go ahead and make these thinner as well. Kind of jumping the gun on some of the more polishy details of this, but sometimes I do that. And that's fine. Yeah, I think that's okay. So now we have these, we want these to sort of do something. Scaling's the easiest to do based on some metrics. So what we can do is we can take the, we have the tile position here, which is the repeated position. I actually want, how do I want to do this? We want the tile sort of indices. And so what I'm going to do is, how do I want to do this? We have this size here. I've done the repetition. I think I'll just do, yeah, we'll just end up doing the same math that these repeat functions do, and that's going to be okay. So we'll do something like, vec2, because we'll get the x and y. So we'll do p.xy minus tile cell, actually it's plus tile cell size over 2. And we don't really care about the range of this. Like, it doesn't have to be like 0, 0, and whatever here. I don't really care about that. Just as long as we get sort of integer values between these different cells. So we'll take this plus cell size over 2. And I think if then we just do over tile cell size, then we can floor this. And that should give us what we want. And then I'm going to take that tile index and do something with it. So easy thing to do here is we can figure this out here, and we'll do the cell size here. Now, I'm going to introduce some discontinuities by doing this because they're going to be different size tiles over the different edges, so we're going to have some artifacts. There's ways around that that we'll deal with, but yeah, bear with me for a moment while I get something that looks nice without fixing the artifacts, because we're going to make things a little slower to fix it as well. Also, I want to move a little bit closer. Yeah. So hold on, my music stopped. We can't have that. There we go. Okay. Yeah, so we just need to do this tile size here. It's going to be scaled by this. Actually, I think all we need to do is saturate FBM and multiply by this. And for the FBM, we need a vec3, and we can just take the tile index for x and y, and then time for z. And there we go. So now they're already scaling. Now I think I only scale these in x, y, which is actually what we want. If I move the time, we get something okay, but we want to kind of make it look a little more better. So what I'm going to do is some scaling of this. Also, you'll notice the FBM is kind of biased, so it never actually really goes to 0, or very rarely does it go to 0, which would actually make these smaller. First of all, scaling time is going to make this a lot more ruly in terms of actually viewing this over time, so it gets a lot smoother like this. Then we can start adjusting for that bias. So I can just do like minus 0.1. And now it looks like we're getting at least one that's going down there. I'll just do a little bit more. Not a problem. And we still have some that go over 1, so this is okay. I'm also going to scale this tile index here. So we get kind of something more like this, where it's a little more continuous across the surface here. That's kind of neat. Another thing we can do is, now that this is like saturated and in a good range, we can do things like put another saturate and pow around it. Always saturate your pows. I actually said that during my stream a couple weeks ago, and I didn't saturate one of my pows, and as I was playing with it after the stream, I had a bunch of artifacts because not saturating a pow ended up making a color that was negative, and when that hit the post pipeline, it actually like went in the depth of field in the bloom and just went nuts. So yeah, always saturate your pows. And as we raise this to different kinds of powers, what it's basically going to do is make the effect a little more extreme, which is kind of nice. At this point, I'm actually going to up the cell count as well. by 2. We can turn the size down a little bit. Yeah, we're already sort of getting the right effect, which is pretty cool. Again, I'm expecting some discontinuities. They don't seem to be as bad as I expected, but we do see them. Like you'll see on the edges here. There's some pretty nasty stuff going on there. So the reason why that happens is because it evaluates the distance to the nearest point on the surface, but because it's in the cell of this cube, it thinks it's like really close to this cube. If I make this bigger, you can see it even more. It thinks it's in this space, so it thinks it's like, as the ray is going over here, it thinks it's, oh, I'm this far from the surface. So it jumps that far, and it jumps into the cube in the neighboring cell. So we have to somehow sort of inject the knowledge of the cell next to it, or do something else. Also, actually, I just cut off half the cubes on the edges again, because this needs to be an odd number. So we'll just add one to this. Not a problem. Oh, that's cool, Danny Cullen. I should add that here as well. That's basically exactly why that happens. Those things are nasty when they propagate. It's like denormals when you write a synth as well. Nasty, nasty things. So generally the easiest way to kind of fix this is what we can do is we can add basically a component to our distance function that instead of describing the actual surface, it will just describe that the ray is close to a surface when it's around the edges of these cubes. And it's kind of a hack, but it should actually work fairly well, except that we go all the way up to the edge on some of these rectangles, so maybe not that great, but should be okay. I'm actually going to... Actually, I think I can write that up really quick. EST? Don't know what you're talking about. Oh yeah, those are nasty. Looking at these. That's what I expected to see. You know, actually, I'm going to do the next part of this, because it'll make it easier when we see if this is messed up later. I'm gonna do the next part of this, which is what I wanted to do is rotate these. So right now we can scale these, like the tile size here. Yeah, John Hunter, this is enhanced sphere tracing, which it still can't handle those just because those are big discontinuities in our distance field. So it's, yeah, doesn't help there. Okay, what I want to do is, yeah, rotate these. So basically the same thing we do here with this to get some random tile size. I want to basically do the same thing. In fact, we can even do this. Tile flip. Didn't like that for some reason. Oh, file flip. Nice. Okay, so we're going to scale it, and then we're also going to flip it, and that should be relatively easy because we can do... we can take this tile position and rotate it by the flip, so we can do... Now, this is not scaled properly, so they won't flip correctly, and also I want to do 1 minus this, so that they flip as they get smaller. But yeah, this goes from 0 to 1 and not 0 to, I believe pi is what we need for half a rotation. Tile type out some pi. And then they should flip. Kind of how I'm thinking. Now, they only flip on one axis. Ideally, we would actually sort of select an axis for them to flip on. Now, that's actually really easy to do. Because we can take sort of this other FBM-ish thing. And we can just select an axis. So we can do flip axis. Do this, and we can just say we have a step function where it steps over 0.5. And what that'll give us is 0 in some cases and 1 in some other cases. Also, I want to offset the time here by a big amount. And what that'll do is it'll, just make it sort of sufficiently different so we just get more random values. Actually, I also don't want to have time as a component in this because we don't want to be switching this axis. We want the axis to be constant for a given cell. So that'll be good. Probably don't need this saturation either, actually. Or this pow at least. I'll take that off. And then we can get rid of one of these saturates. Then what we can do is we can say something like this. Flip tile position. Something like this. However, we're going to do flipped with X and Y. And then we can do this. So we can just mix the two positions. The flipped X1 and the flipped Y1 with this function, or with the result of the step function. Just separate all these out in the lines. Saving that. Now some of these should be flipping horizontally and some of them flipping vertically. And that's pretty neat. Now, one of the problems here is that because the FBM is kind of random in determining which one should be flipped over, it's a bit hard to see sort of the continuity that the original effect had. So I'm actually going to adjust that as well. So right now we're doing this FBM stuff. I'm actually going to do sine. We're just going to do sine of it needs to be based on the tile position. So we can do tile index dot y. Now that should be enough to do something like this, but I want that to be a little bit, yeah, something more like this. And we're also going to add time to that. Now we get something like this. I'm going to reduce how much time we have in there. Make that move slower. That's pretty cool. However, it doesn't look like that many of them are actually like flipping as randomly as I'd like, and probably a lot of that has to do with the scaling of this here. If we bring that up, it should get a little more random. In fact, actually, we don't need FBM here. We actually just want noise. I don't know if I need to saturate my noise function. I don't think I do. But whatever. Multiply this by a big number anyway. However, now it looks like we're seeing patterns here. I might even just use FBM, be wasteful here, just to get rid of these patterns. Now with the flipping, we see the edge artifacts really bad. Still seeing patterns here. Just not what we want. Oh. Sublime looked like it froze for a sec. I'm also going to apply some power to the scaling just to kind of make that like sort of happen with a sort of slightly different curve than the flipping. The other thing I think I want to do, no, we'll just start with that. We just do that's an easy one. Although I wanted the other curve, so we have to do 1.0 minus here, and then we'll do minus here, and then put this in parens. Sweet. Just want to try and break up this flip axis thing here. Also, we need to bias this a bit, I think. The other way. Oh yeah, because I'm biasing here after the saturate. I need to do that before. Or no, I did have that in the right place. Just to make that more random. The other thing I want to do is just generally make this curve a little more better. Do something like this, make this contribution less. We'll get this kind of slant on it. Actually, make that even less. And then I do this saturate pow thing all the time. It's great. Actually, I don't think I need to do this here. I can just do. Oops. 1 minus there. Yeah, just kind of bias that curve. We get less flipping. That's kind of neat. Yeah, saturate just limits the bounds of the number. So it's if it's greater than 1, it'll be 1. If it's less than 0, it'll be 0. Otherwise, it'll be between 0 and 1. Localhost, reading all these functions inside out is weird and a bit error prone sometimes. Dumb question, is there a way to concoct dot chaining syntax in GLSL? I don't think so, just because there's not really like usually you use that dot syntax when you have objects, and there's no real way to do functions on objects in GLSL as far as I know. Because you don't really have the concept of objects. You have structs, but that's more just a collection of values. I mean, it's really just another notation. I don't really have an issue with it because I'm used to it, but I can definitely see what you mean. Raise this to a bigger power, and then we'll get the flip even more like this, and that's kind of nice. So another thing I want to do, Evil says, why don't you use clamp instead of saturate? I actually do use clamp. So my saturate is defined as clamp between 0 and 1. Saturate is normally a function that's available in HLSL, but it better describes what I'm doing because then I don't have to write the 0 and 1 arguments here all the time. So it's just a bit easier to read. But yeah, this literally just is a preprocessor macro that is clamp underneath. So this does work on AMD. Most of the time. Sometimes I mess things up. But it's meant to work on AMD. So now I think I want to fix these edges. It should just be a matter of we take the repeated position. Do bounds hack distance is. So the tile position here after it's been repeated is still centered around 0. And then we have basically this position that we build our cube from. It should just be a matter basically of taking this same thing here. Something similar to that. We're going to take the cell size. That'll give us sort of a bound around the cell. And we want, first of all, we want the opposite of that. So we want sort of the walls of the cell. And then we need to bias this a little bit so that we don't actually hit 0 at the edges of the cell. Because that's basically what we've described here, is an object that is the bounds of each cell. And we don't want to describe that. We want to describe that plus some epsilon. So it should be something like that. And then we can do minimum of the other stuff and this bounds hack. And that didn't work. Classy. But you can see here what we actually described, where we actually described the bounds. So this is what happened. But I think I either did this wrong or didn't make it big enough. The problem is it sort of adds a lot of these bad edges here. As we have to offset it enough that it doesn't slow us down. You'll notice the performance was impacted negatively here. And we're still getting a bunch of the bounce here. If we try to like reduce this, it's just going to cause problems, I think. So to a large degree, this isn't going to be that fixable for the extreme cases. And we're just going to have to live with that. Not terribly concerned about that, to be honest. Yeah, this was a bit worse than I was hoping. Actually, it did help in some of these areas, though, it looks like. But not as much as I'd like. One thing I can do, though. I can intersect. So that bounce hack we only really need when we're close to the object, like within the cell size. So we can also take this and like have bounds around that, so that at least a lot of the rays that are going out here don't have to keep getting close to that edge and far away from that edge. So we can do something like max this tile p.z, take abs of that. That should do it, actually. So then it shouldn't affect our performances negatively, at least. I can start adjusting this epsilon again. And then we should be able to sort of hone in on that surface, I think. Although this is the other problem, is that we're actually going to run out of iterations near the edge if we do this too tight. So some of these artifacts we're just going to have to live with. But for the stream, I think that's okay. It's the kind of thing I'd work really hard to try and find a better solution for in a demo, but we're just playing around with this. It's okay. That's kind of neat. Now, one of the things I wanted to do is, now that we have this sort of sine wave here that goes through this, we can add back the stuff we had as well with the noise function. Sorry, I just realized I'm typing off screen. But all I did is split this into a couple lines. I'm just going to add this. And all that's going to really do in this case is just kind of break that up a bit. In fact, actually, a better place to add that is probably in... instead of doing that out here, we can add this to the sinus that it uses. And that way we don't have to worry about like clamping its value or anything. We can adjust this in a little bit more of a nice way. This line here gets ridiculously long. But that's okay. I can scale this really large, do some fun stuff. Also, if we remove time from this, that'll make things a bit rulier. So then the sine wave will still kind of go through this. 3 is too much here. I can also increase this. Because what I want to do is I still want to sort of capture that like sine wave going through it kind of feel, but I want to break that up a bit. So just kind of adding noise to the input of that sine wave. This is pretty cool. Yeah, doing this with geometry would of course work as well, obviously. In fact, one of the things I need to add in my tool is instancing. And I wanted to do that today, but I was too tired and running too late, so I think I'll probably do it maybe next week. No promises, because who knows, but thinking about it. Because then we can kind of get there without these kind of problems. But this was nice to describe this way, at least. Then again, this would actually be a little more convenient with geometry as well, I think. Because then we don't have to figure out which cell index we're in given a position. We already have that explicitly because we're creating all these different ones. Of course, the way I would do it with instancing is I would actually probably do all this placement and everything in the shader. And then just use the instance ID to figure out where along this grid we would be. And then a lot of those other inputs would basically be the same. But then it would render shit fast, and we could do... like, yeah, quite a bit of these. I mean, granted, we can do infinitely many of these as is, but yeah. We can do many of these as we want. Yeah, that's exactly it, Daniel Cullen. I just realized how weird it is sometimes that I call you Daniel Cullen on the stream. Hello, first name, last name. But makes sense when I'm reading out of the chat. But yeah, that's exactly it. It's just like, if we want to make this something like this fast, it'd be really nice to just have instancing. And I don't mind doing a lot of this like placement and stuff in the shader because I'm just kind of used to that anyway. So it would work out pretty well. This kind of turned out cool. Get some kind of color in here. This will be ugly, but it'll be a starting point. Coder colors. John Hunter says, is OBS running on this computer? Yeah, I run everything off the same machine for convenience. Helps to have a pretty beefy graphics card. Yeah, so I'm looking at that too, local hoster. Is that really poppy stuff that gets back there? I'm looking at the same thing. That's what I would want to bring out in this case. He's talking about this poppy stuff back here. Oops. Not mean to put a key there. Yeah, when this starts getting really shiny. So usually to bring that stuff out, depending on what your environment is, because if you have like a lot of like light up stuff out here, that usually really helps because you have stuff to reflect off of. That's kind of an easy way to get that. Like if you have environment maps, that's really nice. Also reducing the roughness in the material description will help quite a bit. I'll also make it metallic, which will just make it shinier. So then we start getting some pop here, but now we want to sort of bring back a lot of the colors as well. Because it'll start to get a little too extreme if we aren't a little bit careful here. Also, this kind of brings out some issues with the using way too high COC because we get this kind of weird fall off with the depth of field. And we're gonna have a bit of problems with the depth of field in this case anyway, just because there's so much varying distance like between pixels out here. Evil says, any easy way to make those tiles glass? I could probably march through them, but I don't think it'll actually look very good because when you have so much geometry like this with glass, it'll just be edges and edges and edges, and it'll just be aliasing party. So I'm not really sure if that'll work too well. Also, I don't really feel like changing the marcher. Yeah, at this point, I want to adjust colors. Another thing that I like to do at this point is when things start just getting this bright, I just multiply the lights by big numbers to make them like ultra bright, and you start to get a lot more of this, a lot more different kinds of shades, and then I can adjust sort of the materials to bring that out more or less, and things get a little poppier as well. I mean, I'm really just kind of hacking stuff at this point, but this is the kind of stuff I'm thinking about when just playing around with things. John Hunter, woo, aliasing party. Yeah. I'm going to adjust the positions of the lights as well. Also, am not really big on these colors right now. Yet. Well, mess with these until I am. So these are the classic warm light, cool light kind of colors. It's real touchy here. Been kind of into getting more green in these kind of scenarios. Like instead of blue and orange, it's more of a green and orange kind of thing. Been into that lately. But you gotta be kind of careful with that. Oh, sorry, I just realized I'm not typing off screen. Okay, never mind. Something like this starts to get nice. Going to also adjust the fog. Bring that in a little bit because we're going a little too far in the distance right now. Give a smoother fall off here. Had this stupid camera shake. See here as well, the reason why it's so flickery is again just because of aliasing. There's so much stuff going on in the background. And that's sort of the downside to making a lot of this so shiny. We also get way too much bloom, so I got to adjust the material parameters to kind of clean all that up. So we'll get a little less pop, but it'll be all right. In fact, actually just turning down the lights will help here quite a bit. But we'll want to find a balance here. Gives us some nice illumination and some nice pop in the distance there. John Hunter, what we need now is some chromatic aberration, am I right? Do not tempt me. It has a little texture to these as well. By the way, if you notice the frame rate on here, this is too slow. But it's fine for playing around with stuff. So we can turn one of these lights down a bit. Add a little more contrast that way. What was I gonna do? Yeah, it's gonna add texture. So we can just adjust the tile distance here. To do it while it's safe with the flips, but also make it continuous with the nearby tiles might be a bit tricky. Let's just try this. Actually want to do this will make it even slower, by the way. Oops. Oh yeah, this actually needs to be a Vec 3. There we have a bit of texture on there. Still not the most stable thing, but that's fine for now. Also, I totally forgot that I'm still doing reflections here. Totally forgot that. Dark Second, when is it useful to start playing with vertex shaders? Is there anything cool you can do with them? Generally, so the thing is that a lot of the stuff that I've been doing on the stream, at least, just has been like pixel shader based. So it's just like draw everything in the pixel shader. Vertex shaders are obviously necessary to transform actual vertices when you're doing like proper cameras and stuff. Typically, I find that like doing a lot of effects in the vertex shader is not something I typically do very often. But if you've seen our Elysian demo, there's the ball with like all the things that come out and like the white parts that stick out, like with this pixel art stuff. All that's done in the vertex shader. So really, it's about just sort of moving the vertices that build up the geometry. But since we're not working with geometry here, it's yeah, a little bit out of scope. The bad thing about this noise that I added is that it doesn't really follow the rotation, which is a bit unfortunate, but that's just kind of how it is, I think. I think I'll just live with that. Evil says all of these now is lasers and cowbell. And aberration. Always got to put it to 11. Stupid. Actually, this is the kind of thing that mirroring would actually work really well with. So, because you kind of get this like emergent geometry here, which can be really cool. But I would want to do more complex mirroring in this case, I think. And like screen glitches and stuff. I'm actually going to turn down the bloom here. To make it look a little bit more, like, not over bright around the lights. Which can actually make them look brighter. Damn, Colin, you should add elevated sky lasers flying all over this landscape. I actually kind of want to play with spatial stuff here, I think. Like, what if this were a tunnel? Let's find out. I'm going to take out the X stuff here. And we should just be able to polar map this. Like, pretty easily, I think. Do, like, P is... am I thinking... First I'm going to like put this on a different axis, so we can do swap Y and Z, and then it'll make it horizontal. So that's one thing, and then we can look at those. One expensive making video card screen piece of tunnel. That's the point, man. What if the world was a tunnel? What is a tunnel, though? Tunnels are inside all of us. Do that, and then just trying to think how I want to do this. Might as well actually just start writing stuff. I'm a bit too tired to think this through right now. But let's just mess with stuff. I think we just take... I think it's this. Arc10 to get this angle. And then that can be our X. Z stays the same. Let's just throw some numbers in here, see what happens. It's actually this, by the way. P.Y, P.X. So I know this was wrong, but... Weird. Ah, sorry, I didn't mean to have that back here. Hey, Bub Music. I don't know why I'm blanking on this. Happens. You know, honestly, what we could do, though, to do this easier? Let's do this. Right, and that's almost good enough. I think I meant to do minus here. Yeah, it was here. Do this. This should have... So I swap the axis here. If I don't swap this, we'll get... Oh yeah, I forgot. My polar mirror actually works on the y-axis. That makes more sense. Then we can do something like this. Need to do this stuff axis free, but this is fine for now. I think that's what I want to do. Oh no, because now I'm adjusting that. That makes sense because we want this at this point. But then I need to do this still here, I think. One of these will make it work. Hey, Chris. Yeah, I didn't really announce on my Twitter. Like I usually do. Why am I failing at this? Why is that? drop this as well. See if it's easier to see the pattern here. Yeah, so we're getting 3 of these. That makes sense. If we do that after swapping these axes, we should get... Yeah, that makes sense to me. And then we should be able to offset one of these. It's going to move the thing down, which I should have been Y. Maybe I'm not thinking about it right. Right, because this is all swapped now. So if we do that, it should work. And then this will give us the repeating thing. And we may even just need an even iteration for this to work properly, but I'm not sure. Might also just have to rotate the initial one. Let me mess with this some more. About music, yeah, I'm planning on going to Evoke. That's the plan now, at least. Let me just undo all this to make sure I'm thinking about this correctly. Yeah, so we have this. Let me double check my math here. Yeah, so I rotate around the y-axis. So actually, doing this here should make sense. We're going to have these like flaps here. Hey, Evoke should be rad. And Solskjaer. And Tursak. Gotta go to all the parties. Why does this get cut off? What am I missing here? Must be because we only get one edge of it before we rotate. It's gotta be why. Let me try P is P dot ZYX. Because then if I this got so weird. So that's changing the shape, so that's not the right one. Makes it disappear. One of these will do a ton. There we go. Jeez. Okay. Knew it was one of those. All right, so let's... Now the depth of field looks like ass. Oh, so fast. We need to increase some ranges here. Also, I don't... Let's have less of these. Nice hexagonal tunnel. And we're going to increase the depth of field range on this. Let's also move the... I think I also want to move the camera in here. Then we can adjust some other things as well. Gonna actually make these cells bigger, I think, because they're gonna make the whole thing a lot more stable if I do that. Should just be a matter of changing this cell size, and everything should just kind of work out. That's what I expect. That's not terrible. Still mega slow, but, you know. That's how it goes sometimes. Yeah, it needs more mega effects for sure. I think, though, I'm just going to adjust some materials here. Probably call it good. I'm getting pretty tired. Hey, Metal Voids. This thing's nuts. And it's ridiculously slow. That's kind of neat. Disabling the reflections would make it faster. I think the best way to make it faster, though, is to remove some of the... Like, if I remove the noise on the material, that'll make it more stable, too. That'd be the easiest way to do it. Removing the reflections is actually kind of annoying. And so, actually, I can do a quick win for that if I really wanted to. We can do that. So we can just still run the rest of the pipeline, but just not calculate the reflection. Which is just this. That's a bit faster. Doesn't look as cool, obviously. But, you know. That's so slow. Cool, Metal Voids. Congrats. Folks, gonna be pretty cool, it sounds like. But I think I think I'm gonna call it quits for today. Did basically the effect that I wanted to already, and then took it in a cool direction. It's not the world's most expensive tunnel, but it's up there. I can think of some tunnels in Norway that are pretty expensive because you have to bore through mountains. Sorry, I'm tired. I think other things I would do with this, so I would try to make it run faster. I would probably twist the tunnel as well, like on the z-axis especially. Would be kind of cool. Kind of make it turn off at the end as well. Could do some those kind of twisting. And of course put something in it. But I think I achieved what I wanted to achieve today. Another stuff to play with. Thanks there, Colin. Thanks, Local Hoster. And thanks, guys, for watching. I'll see you later.